Okay, so we're getting started back on our videos. We're going to talk about 2.4, linear functions. This is what needs to be done for Friday, so you'll have an understanding of what we're talking about. This is a linear function. A linear graphs a line, so that's all we're talking about, are equations or functions that graph different lines. Standard form for the equation of a line is ax plus by equals c. That would look something like this. Maybe 3x plus 2y equals 7. That's linear. This one may look something like 2x minus 3. Those are both linear, remember, because the highest exponent for both terms is 1. We're going to graph these lines using x and y intercepts. Remember, last time we graphed a line, we just pulled out of the air a couple of x values, plugged them in the equation, and found the y's. We plotted the points and we graphed. This time, we're going to graph specifically using the x and y intercepts. 2 points. That's all we need. Intercepts. The x-intercept is where the graph crosses the x-axis. This is the x-axis right here. So anywhere a line or any graph crosses is going to be an x-intercept. If you notice, what is the y value at every one of these x value points? Well, the y value is 0 at every one of those x's. The x or the y-intercept is where the graph crosses the y-axis. So every x value is 0 at whatever y value we're talking about. That's all you need to know. So if we find the x and the y-intercepts, we can still make our chart just like we did last time. To find the y-intercept, let x be 0. To find the x-intercept, let y be 0. And we just find those 2 points, and we'll have it made. Our function is negative 2x plus 6, so let's let x be 0. Negative 2 times 0 plus 6 is 6. That's it. So 0, 6 is our y-intercept because it's on the y-axis. To find the x-intercept, let y be 0. So, or f of x in this case. So 0 equal negative 2x plus 6. Subtract 6 from both sides, and we have negative 6 equal negative 2x. Divide both sides by negative 2, and we have x equals 3. If you didn't quite catch that, then rewind it. And you can try to follow along one line at a time. 3, 0. 1, 2, 3, 0. And this would be our line. And we just found that line using the x-intercept and the y-intercept. Remember, on the x-intercept, y is always 0. The y-intercept, x, is always 0. If you know that, then you can just plug in and find the other values. This particular line is still a line, f of x equal negative 3. But f of x, we know, also stands for y. Y equal negative 3. Y-axis, go to negative 3. And this one only has a y-intercept. That's a horizontal line. And it's still a function, isn't it? In this particular one, we have x equal negative 3. It's still a line, x to the first power. Go to your x-axis. Go where x is negative 3. And the only choice we have would be a vertical line. The only problem with this one, this vertical line, this x value is used for every y value. 1, 2, 3, negative 1, negative 2, negative 3. Negative 3 happens to be the only x value. That's not a function. It's just a vertical line. So no vertical line is a function. So that's good to know. And then we have the equation of a line in standard form. We do the same thing. It's not a vertical. It doesn't look like that. It's not a horizontal. It doesn't look like that. So we're going to try to graph it using x and y intercepts, 2 points. I need to find the x when y is 0. I need to find the y when x is 0. So let me plug 0 in. Negative 5 times 0 is nothing. So we'd end up with 4x equals 0. So x equal, oh my goodness, x equals 0. If 4x, let's say 4 times 0 minus 5x equals 0, we're still going to have x equals 0, aren't we? So what do we do when we can't find 2 intercepts? It goes through the origin, but that's all we know. One good thing to do would be just pull out some other kind of x value. Let's just say 2. 4 times 2, and then you just have to plug it in your independent variable and find your dependent variable. Negative 5y equal negative 8. Well, that's kind of an ugly number, isn't it? I didn't plan too well there. That is 1 3/5. So when x is 2, y is 1 3/5. We'll just kind of guesstimate there. And that's your graph. So really, it's easier if you can use x and y intercepts, but sometimes they only have one intercept. And in this case, you're going to have to find a third point. And there's also some other ways that we can graph this. We can put it in this form, and you probably remember it as y equal mx plus b form, and pull out our slope and a point. So sometimes when you have a situation like this, you can't graph it by intercepts. We do something a little bit different. Find our slope. There's kind of different things you can do. One thing that you need to remember, though, is find your slope formula. If you remember, slope is, or in your book it'll tell you also, slope is how steep a line is, or steepness of a line. You can have uphill slope. You can have downhill slope or negative slope. That's going in the negative direction, left to right. Slope is also rise over run. Now this delta right here is just a cool way to write the formula. That means change. Change in y, which is the rise up and down, over the change in x, which is the horizontal change. The formula, you subtract your y's, put it over the difference of your x's. So if we wanted to find the slope of a line through this point, negative 4, 8 is something like that, and 2, negative 3 is something like that. We want to find the slope of this line right here, just to kind of put a picture to it. That's what I'm looking for. I know it's negative because I'm going downhill left to right. But according to the formula, the difference in my y's, negative 3 minus 8, over the difference in my x's, 2 minus negative 4. So negative 11 over 6 would be the slope of that line. We could do it again. Slope is the difference in y's over the difference in x's, but we have a problem. That's negative 11 over 0. We can never have 0. Never. So if slope is undefined, meaning 0 is on the bottom, that's going to be a vertical line, just like this right here. So if it looks like this, slope is undefined. If you wanted to graph it, you've got 2, 7, and 2, -4. Oops, up here. And then you've got 2, -4. There's your vertical line. So you can remember that the slope of a vertical line is undefined. The slope of a horizontal line up here, that's no steepness to it. So it would be 0 slope. Difference in the y's over difference in the x's. That is 0 over -7, or slope is 0. So that would be a horizontal line. Okay, I'm going to end that video right there, and you can play it back and forth. Go ahead and write down any questions after you've gone through this a few times, and you can bring them back. The next video will be pretty short. We're just going in and talking specifically about a particular linear equation form, slope-intercept form.